So we've got a hot air balloon, and it's moving upwards at a constant velocity of 8 meters per second. At a height of 120 meters above the ground, a boy on the balloon drops a tennis ball. Now the boy is going at 8 meters per second upwards. The tennis ball is going at 8 meters per second upwards. So we can say the initial velocity is 8 meters per second up of whatever happens. The dropping ball really is what we're interested in. Calculate the time taken for the ball to reach its highest point above the ground. So it is going to be under the influence of gravity, which is 9,8 meters per second squared downwards. And it has its highest point above the ground will have a velocity of 0 meters per second. I can now plug that into an equation of motion, and I get the following. V is equal to u plus at, which is 0 is equal to 8 minus 9,8. Why? Because it's downwards, and we took upwards 8 as positive, and then we find out the time is equal to 0,82 seconds. What is the acceleration of the ball after it has left the boy's hand? Any acceleration in free fall is always going to be 9,8 meters per second squared downwards. The direction is important. Calculate the velocity of the ball when it hits the ground. There are a few different ways of doing this. I'm going to go with the fact that this is 120 meters above the ground. So it's 120 meters down that this ball needs to go. And I'm going to take these conditions over here. As long as I get my directions right, everything should work out just fine. We've done a few examples where we did it both ways, and we know that the signs do accommodate for the changing in direction. So I'm going to go v squared is equal to 8 squared plus 2 negative 9,8 and negative 120, because those are both downwards and the 8 is upwards. When I rearrange that, and don't forget to square root, I get 49,15, and it turns out that it is can be positive or negative. When it's hitting the ground, because when I square root it is positive or negative, when I hit the ground, obviously this ball is going downwards. It does say velocity, so it does expect a direction. Calculate the time taken for the ball to hit the ground after being dropped. I am going to prefer to avoid the equation of motion that's got a t squared in it, and I'm going to go v is equal to u plus at. Final velocity 49,15. Initial velocity is 0. Sorry, I'm going to go with 8 because I don't actually know the time from the top to the bottom. I know that I want to know the full time. What did they ask here? The time taken for the ball after being dropped. So I need the full time. So let's just think about that for a second. My initial velocity is going upwards. My final velocity is going downwards. My acceleration is downwards, and I can then get a time. And it turns out that I get a time of 5,83 seconds. Again, as long as I get my signs right, the right answer will come out. Then it says determine the height of the balloon above the ground at the moment that the ball hits the ground. So what has happened is the balloon was 120 meters above the ground, and for a period of time it continued going up. So I need 120 plus however far it moved during that period of time. It was going at a constant velocity, so I don't need an equation of motion. S is equal to speed times time, 8 times this time that it was in the air for. The ball was in the air for all that time, 5,83 seconds, and I get, so it's 46,65 meters. I add that to the 120. I can't just press plus 120 over here. This equal sign does not mean plus 120. I have to start a new line. Therefore, total height. You can't say it's equal. It's not equal. Equals means the same as. It's not the same as the line before. The total height is 120 plus 46,65, and that turns to be 165,65 meters. The ball bounces off the ground at 35 meters per second. Calculate the height it will reach after the bounce. Not terribly difficult. We're back to a fairly simple question. Initial velocity 35 meters per second up. Final velocity at the top of the projectile 0 meters per second. Acceleration 9,8 meters per second squared down. And therefore v squared equals u squared plus 2as, 0 equals 35 squared plus 2, don't forget negative 9,8 because it's down, and s is equal to 62,5 meters, and that's it. The last question is the trickiest of all. Draw position versus time. Remember, that means displacement versus time graph to represent the motion of the ball from the moment it is dropped from the balloon until it reaches the highest points after bouncing once. Take the point of release as your reference position. So that has to be where x is 0. That's what the reference position means. And you don't need any values on the axes, so they're really just going to look at the shape of this whole thing. So, firstly, I'm going to go like that, and I'm going to put in 0. The first thing that happens is that this ball goes upwards at 8 meters per second, slows down until it reaches 0. I happen to know that that happens after 0,82, but you didn't need anything there. This then comes down and gets steeper and steeper and steeper until such time, by the way, this is displacement meters, time seconds, until it hits the ground, which is a whole lot further on. I mean, I don't know, what was it? It was 166. This is 120 meters below the original position, and this was another 46,65. You didn't have to put those values in, but you had to get this shape right. On the bounce, so just let's think about gradient for a second. I'm slowing down, slowing down, slowing down, slowing down, stopping at the top of the projectile. Speeding up, speeding up, speeding up, speeding up, going past my original position. Continue to speed. That gradient gets steeper and steeper until I hit the ground. At that point, I am going to do a bounce until I reach a height of 62,5. So it's around about there, which means if I've taken 62,5 away from 120, this would be 57,5. Not that I had to put that value in, but that's what it would have been. And it bounces like that. This was a difficult question, and level 4, and only worth 4 marks so that you didn't lose too many. It was really just one for that part of the shape, that part of the shape, that part of the shape, and that part of the shape. Fireworks rocket is launched vertically and runs out of fuel after having reached a speed of 2,5 meters per second. After running out of fuel, the time taken to reach the ground is 4 seconds. So this is 4 seconds over here. In other words, this is from the moment it ran out of fuel, and it was going at a speed of 2,5. Turns out that it was going in at a speed upwards. From this point onwards, it was going downwards. So it must have slowed down, stopped, turned around, reached its original point, and then continued traveling until the ground. That's what would have happened in that picture. The accompany graph shows the motion of the rocket from the moment it runs out of fuel, so at that 2,5 meters per second. What is the velocity of the rocket at point P? 2,5 meters per second, and it's a velocity, so it needs the direction up. The gradient of the graph is 9,8. With what physical quantity does this relate to? Gravitational. You can't just say to me acceleration, man. You know 9,8 is gravitational acceleration. What is the significance of point Q in respect to the motion of the graph? That is where it stops and changes direction at the top of its projectile. You can write at the top of its projectile. What is the velocity of the rocket when it reaches the ground? So we've got an initial velocity of 2,5 meters per second up. And as long as I keep my directions right, I shouldn't stuff it up. My total time is 4 seconds. My acceleration is 9.8 meters per second squared downwards. And if I substitute that into an equation of motion, I land up with V equals U plus AT, 2.5 meters per second up, minus 9.8 because it's down, and then I've got a time of 4 seconds. Sorry, that's a bit messy. And that then turns out to be minus 36.7 meters per second, which means it's 36. I've got to interpret it for the examiner. 36.7 meters per second downwards. Next one. Use the graph to find out the height at which the rocket ran out of fuel. So you're going to say, all right, I'd like to know how high above the ground we were. We know we went up and then down, so these two areas are going to cancel out, but we better calculate them because it's pretty darn tricky to calculate that part of the, I mean, that's a funny shape, it's a trapezium, and we don't even know what that value is over there. So let's go with the whole hog and go displacement is equal to area under curve. Big triangle is equal to a half of 3.75, because it's 0.25 off that, times by 36.7. How do I know that? Because by the end of the journey, that's what the velocity was, 36.7, minus a half of 0.25 on the x-axis and 2.5 on the y-axis. When I work that all out, I get 68.59 meters. Onto a rates question. The curve below shows how the volume of oxygen evolved varies with time of a 2 mole per cubic decimeter solution of hydrogen peroxide, and it's decomposing at 298 Kelvin. They give me this information. It's the volume that I'm producing in certain periods of time. How would you use the curve to find the rate of the reaction? So many of you said to me gradient, which was very nice, but unfortunately it can't get you 2 marks. You need to say draw a tangent at A and get the gradient of the tangent at A. That's how you're going to determine the rate of the reaction. Sketch curves on the axis available on the page to illustrate how the volume would evolve if I used, so let's just do some comparisons. 50 centimeters cubed, 100 centimeters cubed. Remember when we did rates, volume does not change things very much. So volume is not a factor that affects rates. And I'll just remind you why, because, I mean, who knows, you might have forgotten. If I have a container that looks like this, and I've got something happening down at the bottom, it's solid, and then I put that much in there, the site of reaction is over here, okay? What if I put some more volume in? That's going to make no difference whatsoever to the site of the reaction down there. Volume doesn't change things, okay? So we're not even going to consider the volume. But what we are going to consider is the factor of concentration, which has gone down. And if the concentration has gone down, this is going to be a slower reaction. It's going to reach the exact same point of equilibrium, though. Where it runs out, it's going to be exactly the same. It's just going to happen more slowly. X. It's got the same number of particles at the end of the day. The next one keeps the concentration exactly the same again. I've got, in fact, you would have been able to know it went to the exact same point because of number of moles. Number of moles over here is going to be equal to 1 times 100. Over here it's going to be, not 1 times 100, 1 times 0.1. So it would reach a certain point, which is the same as 2 times 0.05, which is not the same, by the way, as a smaller volume at 2 moles per cubic decimeter. that slightly smaller volume is going to mean that I actually only land up with half as much as of a reaction, but it's going to happen super duper fast. So it's going to go wee, and that's going to be your wire. But I'm not going to land up with quite as much product at the end of it. So it's going to go very, very fast, but I'm only going to land up with half as many moles of gas as I did on the other one. They then tell me that hydrogen peroxide decomposes more rapidly in the presence of aqueous hydrogen bromide. In other words, this is going to happen, it's a catalyst for all intents and purposes, and the decomposition proceeds in 2 steps as shown in the following reactions. The reactions, it says put the 2 equations together and write an equation for the overall reaction. So everything on the left, H2O2 plus HBr plus HBrO plus H2O2. So I've taken everything from the left-hand side of the arrows. Then I have taken everything from the right-hand side of the arrows. HBrO plus H2O plus H2O plus O2 plus HBr. Then just like maths, I can cancel HBr on the left, HBr on the right. Just like maths, I can cancel HBrO and HBrO. That's the only things I can cancel. Just like maths, I can add. I've got 2 H2O2s on the left. I've got 2 H2Os on the right, and I have got an oxygen on the right. That is the overall reaction. Provide a reason, other than an increase in the reaction rate, why these equations suggest that hydrogen bromide is behaving as a catalyst. And the reason is that hydrogen bromide is not present in either the reactants or the products. It has obviously been involved, but it has been involved in a catalyst capacity because it is not present in either the reactants or in the products. It then asks you to define a catalyst. You need to look these definitions up, but I'll say it. A substance which changes the reaction rate by modifying the mechanism of the reaction and not only undergoing any permanent change itself. You can't say it is something that does not change during the reaction. It does change during the reaction. It changes the activated complex. It does something to the activated complex. You can't say it does not get involved in the reaction. It's very involved in the reaction. You can only say that it is not changed by the end of the reaction. It does not undergo a permanent change, but temporarily it is involved in changing the mechanism of that reaction. State the effect that a catalyst has on each of the following. It brings down the activation energy, so it decreases the activation energy. It does not change the heat of the reaction because no effect. Because if you think about an energy graph, you're going to land up with that normally. If I put a catalyst in, it's going to land up looking like that. The reactants and the products have not changed, and therefore delta H is exactly the same. The position of the equilibrium is not affected. All that happens is it happens faster. It doesn't change the reaction itself, it just makes the reaction happen faster. This was quite a tricky question, admittedly, but it was taking you to a higher level for the sum total of 1 mark. In another experiment during the decomposition of hydrogen peroxide, students measure the concentration of hydrogen peroxide every 200 seconds. The results are shown in this table. Calculate the average rate of decomposition in the first 400 seconds. The rate of decomposition is change in y over change in x. So it is 0,0131 minus 0,0200 divided by 400 minus 0. And I get an answer of 1,735 times 10 to the negative 5 moles per cubic decimeter, that's the y unit, per second divided by the x unit. Will the rate of decomposition at 600 seconds, here we go, Be greater than, less than, or equal to the average calculated earlier. Give a reason for your answer. It is less than, and I must say I was pretty impressed with most of your answers. It is less because there are less particles to collide as the reaction proceeds. Well done.